Have you ever dropped a coin and watched it fall without anything touching it? Or felt the pull of a magnet on a nail from a distance? These are classic examples of what physicists call non-contact forces. Non-contact forces are those mysterious interactions that occur without any physical contact between objects. Unlike contact forces that need touch, non-contact forces act through fields like magnetic fields or gravitational fields. Let's define it formally. A non-contact force is a force that one object can exert on another from a distance without the need for a medium or surface connection. There are three major types of non-contact forces: gravitational, electrostatic, and magnetic. Each of these is rooted in a fundamental interaction described by field theories. These forces are governed by field laws, for instance, Newton's law of gravitation, Coulomb's law of electrostatics, and the Biot-Savart law in magnetism. They play a central role in both classical and modern physics, whether it's the attraction of Earth's gravity, the repulsion between charged particles, or the interaction of magnets. Let's begin with the most familiar one, gravity. Have you noticed that objects always fall towards the Earth? That's gravitational force in action. Gravitational force is a mutual attraction between any two objects that have mass. This force is always attractive and acts along the line joining their centers of mass. The formula goes like this: F equals g into m1 into m2 divided by r squared, where F is the gravitational force, g is the universal gravitational constant, m1 and m2 are the masses of the objects, and r is the distance between their centers. Even though the gravitational force between everyday objects is weak, when it comes to celestial bodies, the same force becomes immense. Earth orbits the Sun, and the Moon orbits Earth, all due to this invisible but powerful pull. Gravity keeps our feet on the ground, governs the tides, and shapes planetary motion, truly a force of cosmic importance. Now picture this: you rub a balloon on your sweater and it sticks to the wall. What just happened? That's an example of electrostatic force, a force between stationary electric charges. Electrostatic forces arise when objects become electrically charged, either positive or negative, and then interact. Like charges repel, unlike charges attract. The force is mathematically described by Coulomb's law, F equals k into q1 into q2 divided by r squared, where F is the force, q1 and q2 are the magnitudes of the charges, r is the distance between them, and k is Coulomb's constant. Electrostatic forces are much stronger than gravity, especially at atomic or molecular levels. They bind electrons to nuclei, determine chemical bonding, and control lightning bolts in the sky. Have you ever played with magnets and felt them pull or push without touching? That's the magnetic force, another non-contact force. Magnetic force is the interaction between moving electric charges or magnetic poles. Like magnetic poles repel, and unlike poles attract, just like charges, but governed by different laws. This force is produced by moving charges or currents and is described by the Lorentz force law, where F equals Q into V cross B. Here, F is the magnetic force, Q is the charge, V is the velocity of the particle, and B is the magnetic field vector. Magnetism powers electric motors, guides compasses, and allows maglev trains to float over tracks. It's also the principle behind data storage in your computer hard drive. Now let's step out of the textbook and into the world around us. You'll be surprised how non-contact forces are everywhere. In everyday life, gravity pulls water down when you pour, electrostatic charges cause your hair to stand after removing a sweater, and magnets are used in MRI machines in hospitals. In space exploration, gravity assists are used to slingshot spacecraft using planets. Magnetic fields help protect Earth from solar winds, shielding life on our planet. In industry, electrostatic forces are used in precipitators to clean smoke in chimneys. Magnetic separation helps purify minerals in mining. And in particle accelerators, electric and magnetic fields guide high-speed particles. These forces, though invisible, are the very scaffolding on which many technologies are built. Let's work through an advanced level example based on electrostatic force. Suppose we have 2-point charges, Q1 equals plus 4 microcoulombs and Q2 equals minus 2 microcoulombs, separated by a distance of 0.3 meters. Using Coulomb's law, force F equals K into Q1 into Q2 divided by R squared. Substitute the values. F equals 9 into 10 raised to 9 into open bracket 4 into 10 raised to minus 6 close bracket into open bracket negative 2 into 10 raised to minus 6 close bracket divided by open bracket 0.3 close bracket squared. Solving this gives F equals negative 0.8 newtons. The negative sign indicates that the force is attractive because the charges are opposite. So, these two charges will experience a mutual attraction of 0.8 newtons. Let's quickly revise what we've uncovered about non-contact forces. They are forces that act without physical contact through fields like gravitational, electrostatic, and magnetic fields. Gravitational force arises from mass, electrostatic force from charge, and magnetic force from moving charges. These forces obey inverse square laws, meaning their strength decreases with the square of the distance. They operate across space, shaping everything from falling apples to planetary orbits, electric sparks to MRI scans. I hope now you realize physics is not only about visible pushes and pulls, but also about invisible interactions that hold our universe together. See you in the next topic, where we'll dive deeper into the dynamics of motion and explore even more incredible forces at play.